A transparent bowl is prepared as the primary container for the experiment. The bowl is filled with water to create a still, reflective surface. The water's stillness is crucial for clear observation and accurate results. The setup is arranged on a table to provide a stable and accessible platform. This controlled environment allows for focused study of water surface phenomena. Various objects, such as stones, leaves, plastic spoons, and coins, exhibit distinct characteristics. Each object has a unique shape that defines its outer form and structure. The size of each object varies, influencing its physical dimensions and volume. Objects are composed of different materials, such as stone, organic matter, or plastic. These differences in shape, size, and material contribute to the diversity of objects in our environment. A stone is introduced into a container of water. The stone's density is greater than the water's density. The force of gravity acting on the stone exceeds the buoyant force of the water. Consequently, the stone experiences a net downward force. The stone sinks to the bottom of the container. An object sinks in water when its density exceeds that of water. Density is defined as mass per unit volume. The stone sinks because its weight is greater than the buoyant force. Buoyant force is an upward force exerted by a fluid that opposes the weight of an immersed object. When the weight of the object exceeds the buoyant force, the object sinks. A leaf is carefully placed on the surface of the water. The leaf is observed to float. The leaf remains on top of the water. This demonstrates the leaf's ability to be supported by the water's surface tension. An object floats when it is less dense than the fluid it is in. Density is a measure of mass per unit volume. A leaf floats because its density is less than the density of water. The buoyant force acting on the leaf is greater than or equal to its weight. A plastic spoon is used in this demonstration. The spoon is gently placed on the surface of the water. Observation: the plastic spoon floats. This demonstrates buoyancy, where the upward force of the water equals the spoon's weight. The spoon's shape and material contribute to its ability to displace enough water to float. A plastic spoon can float due to its specific shape and material composition. The spoon's design allows it to displace a certain volume of water. This displacement generates an upward buoyant force. If the buoyant force equals or exceeds the spoon's weight, it will float. A coin is released above a container filled with water. The coin enters the water. The coin rapidly descends through the water. The coin comes to rest at the bottom of the container. The coin's density is a key factor in its behavior in water. The coin is denser than water, meaning it has more mass per unit volume. The weight of the coin is determined by its mass and the force of gravity. Buoyant force is the upward force exerted by a fluid that opposes the weight of an immersed object. Since the coin's weight exceeds the buoyant force, it sinks to the bottom. Density is a key factor determining whether an object floats or sinks in a fluid. An object will sink if its density is greater than the density of the fluid. Conversely, an object will float if its density is less than the fluid's density. A stone sinks because it is denser than water, while a leaf floats because it is less dense. Buoyant force is an upward force exerted by a fluid that opposes the weight of an immersed object. The magnitude of buoyant force depends on the density of the fluid and the volume of the object submerged. Objects with a lower density than the fluid will float due to a buoyant force greater than their weight. Objects with a higher density than the fluid will sink because their weight exceeds the buoyant force. A stone experiences buoyant force, but its weight is greater, causing it to sink. A leaf experiences buoyant force sufficient to counteract its weight, allowing it to float. Volume displacement is a method used to determine the volume of an irregularly shaped object. A graduated cylinder is partially filled with a known volume of water. The initial water level in the cylinder is carefully recorded. The object, in this case a stone, is then submerged into the water. The stone displaces a volume of water equal to its own volume. The difference between the final and initial water levels indicates the volume of the stone. The volume of water displaced by an object is directly related to the object's own volume. Archimedes' principle states that a buoyant force acts on a submerged or partially submerged object. This buoyant force is equal to the weight of the fluid displaced by the object. Therefore, the upward force counteracting gravity depends on the density and volume of the displaced fluid. This principle explains why objects float or sink based on their density relative to the fluid. An object's behavior in a fluid is determined by the relationship between its weight and the buoyant force acting upon it. Weight is the force exerted on an object due to gravity, pulling it downwards. Buoyant force is the upward force exerted by a fluid that opposes the weight of an immersed object. When an object's weight exceeds the buoyant force, the object sinks. This imbalance indicates that the gravitational pull is stronger than the fluid's resistance. The greater the difference between weight and buoyant force, the faster the object will sink. The graphic illustrates the interplay between a leaf's weight and the buoyant force it experiences. Weight is the force exerted on the leaf due to gravity. Buoyancy is the upward force exerted by the fluid, air, displaced by the leaf. For the leaf to float, the buoyant force must be equal to or greater than the leaf's weight. This balance allows the leaf to remain suspended in the air rather than sinking. The graphic visually represents this equilibrium, demonstrating the principle of buoyancy in action. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. The shape of an object significantly influences the amount of fluid it displaces. Objects with shapes that displace more fluid experience greater buoyant force. Different shapes made from the same material will displace varying amounts of fluid. Aluminum foil, for example, can be shaped to float or sink based on its form. This demonstrates that buoyancy is not solely determined by material, but also by the object's geometry. The shape of an object influences the amount of water it displaces. Water displacement is directly related to the buoyant force acting on the object. Objects with shapes that displace more water experience a greater buoyant force. Conversely, shapes that displace less water result in a weaker buoyant force. Therefore, shape is a key factor in determining an object's buoyancy. Understanding this relationship is crucial in fields like naval architecture and fluid dynamics. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. This force allows objects, like ships, to float. Ships are designed to displace a large volume of water. The weight of the displaced water equals the buoyant force acting on the ship. If the buoyant force is equal to or greater than the ship's weight, the ship floats. This principle enables ships, even those made of dense materials, to float. A boat's design is crucial for its ability to float. The shape of a boat allows it to displace a significant volume of water. Displacement refers to the amount of water the boat pushes aside. This displacement creates an upward force known as buoyancy. Buoyant force counteracts the boat's weight, preventing it from sinking. When the buoyant force equals the boat's weight, the boat floats. Density is a fundamental property of matter. It is defined as mass per unit volume. The equation to calculate density is density equals mass divided by volume. This equation shows the relationship between density, mass, and volume. Density is a measure of mass per unit volume. It quantifies how much matter is packed into a given space. Density is typically expressed in units like grams per cubic centimeter, (g/cm cubed (br). Kilograms per cubic meter, kg, m cubed, is another common unit for density. Understanding density units is crucial for interpreting density values. These units provide context for comparing the densities of different materials. Objects that sink demonstrate a density greater than the fluid they are placed in. A metal key serves as a real-world example of an object that sinks. Objects that float exhibit a density less than the fluid they are placed in. A cork provides a real-world example of an object that floats. Density is a key factor determining whether an object will sink or float. These examples reinforce the concept of density through observable phenomena. Encourage exploration of various household objects. The task involves predicting whether each object will sink or float in water. This activity promotes hands-on learning and observation skills. Experimentation helps understand concepts of density and buoyancy. Density, buoyancy, and displacement are key factors determining if an object sinks or floats. Density is the mass per unit volume of a substance. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. Displacement refers to the volume of fluid that is pushed aside when an object is submerged. An object will float if the buoyant force is equal to or greater than the object's weight. Otherwise, it sinks.